Welcome to the beginner video series for the GRE. This is the second video on probability. If you have not watched the first one, please watch it before continuing with this video. In the previous video, we had done some questions which involved cards. In this video, the questions will involve dice and coins. Now let's say you have a 6-faced dice. If you roll it twice, these are all the possible outcomes that you can get. You can get 1-1, you can get 1-2, 1 on the first roll, 2 on the second roll. You can get 1-3, 1-4, 1-5, 1-6. Similarly 2-1, 2-2, 2-3, 2-6. Similarly 3-1 up till 3-6. Then 4-1 up till 4-6. 5-1 till 5-6. Then 6-1 to 6-6. So if you count, these are 6 times 6, 36 outcomes. So if you roll a 6-faced dice twice, you will get exactly 36 outcomes. Now this question is, what is the probability of obtaining a sum of 3 when rolling a 6-sided dice twice? Probability is favorable upon total. Now if you roll a 6-faced dice twice, the total number of outcomes that you can get is 36. So total is 36. Favorable outcomes are those outcomes in which sum is 3. Sum is 3 in only 2 outcomes, 1-2 or 2-1. So favorable outcomes are 2. Hence our answer is 1 upon 18. Hope this is clear. We'll move ahead. Now coming to coins. I would want you to pause the screen and solve this question. I hope you've done so. It's a difficult one. Let's solve it together. If a coin is tossed 6 times, what is the probability of obtaining exactly 2 heads? Now, if a coin is tossed 6 times, what is the total number of outcomes we can get? Let's find out. These are the 6 outcomes. On the first toss, you can get either head or tail, so 2 outcomes. And means multiplication, and in the second toss, you can again get 2 outcomes. And in the third toss, again 2, and 2, and 2, and 2. So total, you can get 2 to the power 6 outcomes. If you toss a coin 6 times, probability is favorable upon total. So total is 2 to the power 6. Now favorable outcomes are those outcomes in which there are exactly 2 heads. There are exactly 2 heads. Exactly 2 heads means exactly 4 tails, because a coin is tossed 6 times, right? So this is one favorable outcome in which first 2 tosses give you head and the next 4 give you tail. Similarly, another favorable outcome would be this. On the first toss and the third toss, you get head, and in the remaining 4 tosses, you get tail. Similarly, another favorable outcome would be this. So there are multiple outcomes in which there are 2 heads and 4 tails. Now, how do we find the total number of such outcomes? You can treat this as a letter arrangement problem or a word arrangement problem or objects arrangement problem, which we had discussed in the permutations and combinations chapter. You can treat it like object arrangement problem. There are 6 letters here. The 6 letters here, they can be arranged in 6 factorial ways, right? Now, how many words can you form using these 6 letters? 6 letters, so 6 factorial. H is present twice, so divide by 2 factorial. T is present 4 times, so again divide by 4 factorial. So these are all the words you can form which have 2 H and 4 T's. Hence, these are all the favorable outcomes. Okay. If you find out how many words you can form using 2H and 4Ts, you will get all the outcomes which have exactly 2 heads and exactly 4 tails. Okay, so these are your favorable outcomes. So favorable outcomes are 6 factorial upon 2 factorial times 4 factorial. Hence our answer is this. You can simplify it and get to a refined form. Okay. A bit challenging this question, but let's move ahead. Now these are some additional practice questions for you to try. Pause the screen and give it a crack. I hope you have attempted all these questions. Now let's solve each of these one by one. The first one, what is the probability of rolling either a 4 or a prime number on a fair 6-sided die? Or means addition. What is the probability of getting a 4? Now favorable outcomes is 1, total outcomes are 6. Favorable outcomes is 4, which is 1 outcome. So 1 out of 6, 1 upon 6. How many prime numbers are there from 1 to 6? 2, 3 and 5 are the prime numbers. So there are 3 prime numbers. Probability would be 3 upon 6. So this becomes 4 upon 6 or 2 by 3, and that's our answer. Let's move ahead. The second one, there is a 20-sided die numbered from 1 to 20 and it is rolled twice. What is the probability that the resulting product is an even number? Now product will be even where out of 2 at least one number is even. Product will be even when first is even and second is odd, or means addition. First is odd and second is even, or both are even. Product is even when at least one of the 2 numbers is even. Okay. Now what is the probability that first is even? Now there are 20 numbers in total. From 1 to 20 there are 20 numbers. Half are even, half are odd. So probability is 10 upon 20. There are 20 even numbers and the total numbers are 20. Favorable are 10, total are 20. This is the probability that the first number is even and the second number is odd. Again, there are 10 odd numbers out of 20. So 10 upon 20 is the probability. This is 1 upon 4. Or means addition. First is odd, the probability is again 10 upon 20 because there are 10 odd numbers out of 20 total numbers. Second is even, probability is again 10 upon 20. Here we will not do 10 upon 19. The denominator will not be 19 because the second outcome would also come out of the 20 total outcomes. It's not like cards. In cards, if you select one particular card, you cannot select the same card again. But in dice, if you get 5 on the first roll, you can get it again. Right. So second outcome will come out of 20 outcomes, not out of 19 outcomes. So this is 1 by 4. Again, addition. First is even, probability is 10 upon 20. Second is even, probability is 10 upon 20. This is also 1 by 4. So the answer is 3 by 4. There's another way to do it. From the total outcomes, from the total probability, if you subtract the probability that product is odd, you will get the probability that the product is even. That is what we are asked. Total probability is always 1. What is the probability that the product is odd? Product will be odd when both the numbers are odd. Probability of the first number being odd is 10 upon 20 and the second number being odd is also 10 upon 20. This is 1 minus 1 by 4, which is 3 by 4 again. Okay. From the total probability, if you subtract the probability that the product is odd, you will be left with the probability that the product is even. Let's move on. In the third one, we are given 5 fruits A, B, C, D, E that are to be consumed. What is the probability that apple and banana or A and B are not eaten consecutively. So what is the probability that if you arrange A, B, C, D, E, A and B are never together? From the total probability, if we subtract the probability that A and B are together, we will get the probability that A and B are never together, right? Total probability is always 1. What is the probability that A and B are always together? Let's find the number of ways in which you can arrange A, B, C, D, E such that A and B are always together. If A and B are always together, take them as one object. The other objects are C, D, E. So in total you have 4 objects because you have taken A and B as one object. 4 objects can be arranged in 4 factorial ways. A and B, these 2 objects can be arranged among themselves in 2 factorial ways. So these are the total number of ways in which you can arrange A, B, C, D such that A and B are always together. These are our favorable outcomes. Total outcomes means total ways you can arrange A, B, C, D, E, which is 5 factorial. And this is the answer. From the total probability, we have subtracted the probability that A and B are always together. And we have got the probability that they are never together. I hope this is clear. Let's do the 4th one now. If Thalaivar consumes idli, dosa, appam each once a year, okay, what is the probability that he will eat all 3 items on the same day in 2025? Now, I have checked, 2025 is not a leap year and there are 365 days in 2025. So what is the probability he will eat idli, dosa, appam on the same day? Now let's say he eats idli on any day. The probability of him eating idli on any day is 1. He can eat it on any particular day. Probability is 1. Okay. Now what is the probability that dosa is also consumed on the same day? He has already eaten idli on any particular day he likes. What is the probability that dosa will also be consumed on the same day? The probability would be 1 upon 365 because total days are 365 and the favorable days is 1. There is only one particular day. And what is that day? The day he consumes idli. Okay. For the case of idli, all the 365 days were favorable days. He could have eaten idli on any of the 365 days. So 365 upon 365 is 1. Now what is the probability that he consumes appam also on that same day? Again 1 upon 365. Total there are 365 days and favorable day is one particular day in which he consumes idli and dosa. And this is our answer. 1 upon 365 square. Now if the question was, what is the probability that he will eat all the items on, let's say, January 1st, 2025, then the solution would be different. Okay. Now, what is the probability that he would eat idli on this particular day? 1 upon 365, right? Favorable day is one particular day and the total days are 365. Probability of eating a dosa on that particular day is also 1 upon 365 multiplied by 1 upon 365. The answer in this case would be 1 upon 365 cube. But in the original question, he could consume idli on any particular day and then we have to find the probability that dosa and appam are also consumed on that day. Okay. So these two questions are different and their answers also differ. With this, we come to the conclusion of this video. I'll see you in another one. Thank you and have a nice day.